Hi there, welcome back. Well, time for some alignment of this Grundig 90U set. I think everything else is practically done. So I'm going to start with the AM-IF alignment. And to do that, I've got the instructions on the screen. I've got my signal generator connected. I've got my oscilloscope, although you don't really need it, but I prefer it. And I've got an analog meter. And the reason I prefer an analog meter is because it's a lot easier to see the movement of the needle than to watch digits on a multimeter, a digital multimeter. But basically, what I'm going to do is I'm going to feed a signal into the radio from the signal generator at the IF frequency. And I'll be aligning the IF transformers to get the biggest or the best signal coming out. Now, everyone's got their favorite method of doing these alignments, and you can actually go to the instructions they give you, but I've done quite a few of them, and I'll tell you what I'm going to do. The IF frequency for the AM is 468 kilohertz, which is sort of unusual, okay? It's not 455 or 460 like you normally would find, but 468. So 468 kilohertz is going to be fed into here, and it's going to go through there. It's going to go through the first IF transformer, which we need to peak. In other words, we need to tune it so that the 468 kilohertz gets through as clearly as possible. It then goes to this EF89, which is an IF amplifier. It goes through that IF transformer, and these are the two coils that you need to peak in this case. And again, you're trying to make the 468 go through as well as possible. And the way to detect how well it gets through is, there are various ways of doing this again, but I'm going to measure at the speaker. And what I'm going to measure is the amplitude of the audio signal that I'm going to send in with the 468 kilohertz. So first of all, I've got 468 kilohertz. Amplitude, I've made it as small as I can. I can't make it any smaller on the signal generator. So I've got a carrier which is 468 kilohertz, which is the IF frequency, and it is at a very small amplitude. Okay. I then modulate it with a AM modulation, an AM frequency of 600 Hertz, that's the tone I'm looking for at the output, and I'm going to modulate 30%, all right? And the modulation is on, and the signal is on. Now, because the signal that's coming out of there is 1.4 millivolts, and it's probably too high for this, I've got this attenuator, it's AC coupled, so there's a cap in there, stops any DC from actually coming back into the signal generator. And I can attenuate 18 dB, plus 12 dB, plus 6 dB, or any combination of these three numbers. I'm going to start off with 18 dB attenuation and see what the signal is like at that end. If it's too high, I can add another 6 dB or even add another 12 dB. Actually, I'll start with 30 dB of attenuation. This then goes off to the radio. The ground of the signal generator is connected to the chassis ground, and the signal itself is connected to that grid of the ECH81. It's pin 2, and there's actually a 1 mega ohm resistor that's conveniently soldered to that. That's what I've got the crocodile clip connected to. So we're ready to send the signal in. The instructions also tell us to do the alignment on long wave. So I've put in long wave, and I'm tuning sort of at the middle of the band somewhere. And then I've got the AC voltmeter connected to the speaker terminals coming out to the speaker. So I'm measuring straight across the speaker, and that speaker, or that output, is connected to my dummy load over there, and I can choose between speaker or dummy, and if I choose dummy, I'll put it on 4 ohms. because this thing says it's got a 3 ohm speaker. And then I've got that channel going to the oscilloscope, and I'll be monitoring the signal on the scope, which we don't really need in this case, but I like to see it anyway. I have it on, and I can't hear anything on the speaker. Actually, it's on dummy. Oh, I can hear it now. Speaker's on the shelf over there. I can hear it. I can see some tone on here. That would probably be a better range. There's still quite a bit of static, but it's enough for me to see the result. And here, I can see that as well. This is actually averaging, just so that I get a clearer picture, but I can put it on normal. That's what it looks like. Okay. So that's a very weak signal, but it's good enough for testing. However, what I want to do is I actually want to see what it's tuned to. In other words, what I'm going to do here is I'm going to go to here and I'm going to start changing this up and down and see at what frequency I get the best signal, to see if it's tuned anywhere close to 468. We'll look at the meter for that, and I'll show you what the result is. Okay, what I'm going to do is I'm going to put it on dummy load so that we don't have to listen to that tone, which can get a bit annoying. And now I'm going to move the frequency, adjust the frequency that's coming out of the signal generator. It was 468, that's 469, that's 470. Obviously, it's not there. 468 again. That's 468. That's 467, 468, 469. So it seems to be on 468. Let me go a little bit finer. That seems to be the peak. And what I actually get on here, in other words, I've peaked it as it is. Let me see if I move further away what happens. It goes lower. And it goes lower. So there's my peak. That's about my peak. Okay, what frequency is that? That is actually peaked at 468.4. And I'm not even sure that it is peaked. In other words, that is the peak that it is seeing. I am not sure whether I can adjust it and get a better result. Now at the moment, I've got 30 dB attenuation on that little attenuator. So this signal is very small, but it does seem to give us the right signal to tune with. And what I've got is a signal that's small enough that it doesn't mess with the AGC, the automatic gain control, on the radio. So now what I'm going to do is I'm going to start adjusting those coils. Now, as I told you, those coils at the top, it's the one on the outside over there, and this inner one is the one closest to the other transformer. That's the one, those are the two that I'm going to be adjusting. And on the underside, I've got to get to that guy in there, the bottom one, and I've got to get to, damn, you can hardly see it, there's a resistor in the way, that guy in there, the one on the right. So those are the 4 cores I'm going to be adjusting, and while I'm doing that, I'm going to keep the meter or the camera on the meter and see what we get. And for the sake of reference, just so we know if we made any improvement or not, as things stand at 468.4 kilohertz, my reading is, that thing's on 0.3, I'm getting about 0.09 volts. So the setting is on 300 millivolts. The 300 millivolts is on the bottom, that's 100 millivolts. Now I'm getting 90 millivolts RMS there. Let's see what happens when we adjust it. I'm going to set the signal generator again to 468. So that's 468, so it came down a little bit. And now I'm going to start making the adjustments and see what happens. There's a bit of improvement. That's a peak. The other one, I'm doing the underside ones first, doesn't really matter. Whoa. Well, that sort of slipped the whole core in for a while. I've got it back. I had to use a metal screwdriver with some heat shrink on there just to get it back. I've got the wooden one back in here. And there's our peak. Okay, two of them. Now the top. Top ones. Oh, that's nice. That is really nice. That's really peaked up nicely. That's a peak, and the other one. Whoa, that's going off the scale. Okay, we know we don't have to compare to the other one. I'm going to give it another 60 dB of attenuation because that's just far too strong a signal. We know that this thing has definitely peaked dramatically. There is the new peak. That seems to be it. Let me just try the other one again. Okay, we've peaked it. And what have we peaked it at? Well, we've actually got it on another 60 dB of attenuation. So we've actually halved the signal. And we've got it at, what is it, 100 and it's 300 millivolts, 180 millivolts, 360 millivolts. This thing went up way high, way high. Now, it's on 0.3 anyway, but I did half the, I put another 6 dB of attenuation on there. So I basically halved the signal strength, and we're getting almost double the strength over there. And that, my friends, is peaked. That is peaked. That's all there is to it. And what you saw me do was adjust that one there and the one on the bottom, the corresponding one on the bottom, that one there and the corresponding one on the bottom. And that is all. That is my IF alignment for the AM at 468 kilohertz. Now we'll just see what reception's like. Should have improved. This is long wave. There's our beacon. Don't expect much else on here. Medium wave. Pretty good. This is Canary Islands. This is North Africa somewhere. Unbelievable.
En España, rueda de prensa que podrán escuchar en Radio 5 Todo Noticias, también Fernando Simón, director del centro.
Well, this thing is receiving better from the Canary Islands than it is our local AM station. We have one AM station in Madeira. The reception from the Canary Island stations, which is, what is it, I don't know how many hundreds of kilometers away, is better than our local one. So the alignment here, although it was supposedly aligned to 468, my feeling is that it was probably too wide. the actual tuning band, the actual alignment curve was probably too wide, so therefore the signal was weaker. And I've just sharpened it up and I've aligned it properly to 468. And I'm happy as a pig in mud. That's it. That's the AM alignment done. The AM IF alignment done. Okay, for the FM IF alignment, I'm going to feed the IF frequency, which is 10.7 megahertz. And I've got a 70 millivolts RMS signal here. It's supposed to be lightly coupled to DCC 85, so I've just got it around a little coil that I slip over the tube. And then I'm measuring the voltage on the ratio capacitor down there, referenced to ground, on the voltmeter. So here we go. Let's see if we get anything. I'm doing the one on the other side. It's quite a difference. There's my peak. Quite a difference there. Let's go to the top. Oh, that has peaked, that's okay. Let's go to the other one. There's my peak, okay. And they've peaked. Now, the final one, which is coil B at the bottom there, what they tell you to do is to actually modulate it with a AM signal. So what they're actually asking you to do is to feed the 10.7 megahertz with AM modulation. You're going to make it AM modulation, depth of 30%, 600 hertz signal, and send that. And what you're doing is you're sending AM on your FM signal, on your FM carrier. And basically what you're trying to do with that, that final winding on that transformer is AM rejection, because with FM you don't want to get AM. And one of the ways of tuning that is to get this so that your AM signal, your audio signal, AM modulated, comes through as low as possible. Now I can see it there, and I can hear it. I've got to get that to, now it's going up on the other side, so I must get it to a minimum. That seems to be it. Now if I put FM modulation, let me try that. Let me put this on dummy. Now I've got an FM modulated signal and I'm getting a perfect sine wave. So that's great. And I think some of the distortion we had earlier is gone. I can still try and improve that sine wave a little bit. No, it's as good as it gets. I've got a perfect sine wave being modulated on there, FM modulated, which means that I've got that thing more or less pretty well balanced. And that's it. I've done the FM alignment. Very simple method on a very simple radio. Let's see what reception's like.
De menos importância é largamente compensada pelas medidas que o governo nos anunciou e positivas. António Saraiva, da Confederação Empresarial de Portugal, só mais uma nota: até dia 15 ficarão fechados os
argumenta o tributo dizendo: se a nossa história é desconhecida e somos...
That's pretty good. There are a couple of stations here that I'm picking up now that I wasn't picking up earlier, and I don't think the distortion is there. So I think our FM alignment is done. And that is where I'm going to stop for today. So what do I have left to do? I have to do the chassis, put this in the chassis, do the final testing in the chassis. But that's something I'm probably going to have to do over the weekend and report to you early next week. So for now, that's it. I want to thank you for watching. If you've enjoyed that, please click the like button. It does help the YouTube algorithm to recommend the videos a lot more. And you can also share it on social media and subscribe to the channel and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Thanks for watching. Bye for now and stay safe.